Hi, I'm Baylor Fox-Kemper from Brown University, and I was a coordinating lead author of the Working Group 1, a sixth assessment report of the IPCC, and I'm presently the co-chair of the CLIVAR Ocean Model Development Panel. I'm going to talk a little bit about how DOOS science can contribute to those kinds of groups. One of the big breakthroughs in the AR6 was the breakdown of the global energy budget, constituent by constituent, or reservoir by reservoir, and the sea level budget, constituent by constituent. Observing each of the constituents and then summing them up and comparing to the total change, we can see if there are any missing ingredients in either of those budgets. As you can see, the ocean plays a dominant role in the energy inventory and a very large role in the sea level budget. Over 90% of the energy in the Earth's system ends up in the oceans, and a good fraction and a growing fraction ends up in the deep ocean, deeper than 2,000 meters, the darkest blue here. Similarly, a considerable and growing fraction ends up of the sea level budget ends up in the deep ocean. When we go to look forward into the future, not just from observations, we think about whether models are correctly representing that ocean thermal expansion. And in that case, you can see that with each of these little pink squares representing 1 centimeter of sea level rise since 1900, about half of the sea level rise, regardless of scenario and regardless of year, comes from the ocean thermal expansion. Where in the water column that ocean thermal expansion sits is a challenge for models because the vertical distribution depends on a lot of complicated subduction, eddying, boundary layer, and circulation questions that differ among the models. One really interesting dynamical aspect of the deep ocean is the low stratification there, and that low stratification tends to make the eddies quite small. In particular, the submesoscale instabilities that I'm quite interested in of the bottom boundary layer are very small, order 1 kilometer, as we just showed in this paper led by Jihai Dong, my colleague. Thank you.